first thing that we're going to do today is talk about a monomial. Does anyone have thoughts on what a monomial is? What's a monomial? Yeah? A digit with one exponent, I can see that. It would be considered a monomial, but that's not all a monomial is. It could be more than that. Thoughts on a monomial? Nobody? Oh, guys. Come on. All right. We'll do it the boring way. I'll talk. A monomial is a number or a variable or the product. Do we remember what product means? Say again?
Multiplication.
Multiplication. Specifically, the answer to a multiplication problem, right? So the product of a number and one or more. That's supposed to be a 1, I promise. Let's fix it. Where's my eraser? There's my eraser. One or more variables with non-negative integer exponents. All right, so it is a number or a variable or the product of a number and one or more variables. And those variables should have non-negative integer exponents. So, first question. The number 10. Is the number 10 a monomial? What do you think? Why not?
Because it needs more than one variable.
No. No, look at the definition again. A monomial is a number or a variable or the product of numbers and variables with non-negative integer exponents. So the number 10, is it a monomial?
Yes.
Yeah, definitely. Yes. F plus 24. Is that a monomial? No. Nope. It is not. Why isn't it? What is it that's making it not a monomial? Yeah. It's adding instead of multiplying, right? The monomial says nothing about adding or subtracting. It only talks about multiplication, right? So because there is an addition symbol, then it's not a monomial. So there is addition. That is why it is not a monomial. And when there is addition, you get more than one term. And a mono means, what does mono mean? One. And so monomial specifically means one term. And so as soon as you throw addition in there, you get more than one term. H squared. Monomial? Yeah. Yep. J? Monomial? Yeah. 23ABCD squared. Yes. A lot going on in that one, but it's all multiplication. So we're good to go. XYZ squared all over 2.
No.
Yes.
What? Still no idea.
Say again. This is a monomial, and the reason it's a monomial, I know a monomial says nothing about division, right? It says multiplication, but division by 2 could be rewritten as what? Times 1/2. And 1/2 is a number, right? So I can take this and turn it into 1/2 XYZ squared, right? And so the answer to this one is yes. All right, what about the last one? No, why not? Yeah, you can't change this into a number times all multiplication, right? When you put a variable in the denominator, now you are dividing by something, right? And nowhere in my definition did it talk about division by a variable. It talks about multiplication. And so the answer to this one is no, and the reason is division with a variable. So you are not allowed to divide by a variable and still be called a monomial. Does that make sense? All right. Now, let's talk about constants. What is a constant? Does anyone remember what a constant is? Yeah. Say again? Something that stays the same. Yes. That's the definition of constant. What about in math? What's a constant in math called? Or not called, but what is it? Yeah. There's no variable, right? It's just a number. So when we talked about that first problem, which if you remember was 10, right? So when we talk about the number 10, right here, 10 is a monomial, but it also has another name. It's called a constant. And so a constant is a number with no variable, right? A number with no variable. All right. So that takes care of our definitions. Now, let's talk about 3 raised to the 4th power. Let's see if we can't identify the pieces here, because we have to be able to speak the same language. If I have 3 raised to the 4th power, what is the 3 called? Called the what?
The base.
That's called the base. So when you have a power, the thing, the big number is called the base, right? And then the 4. The 4 is called the what? Starts with the letter E. Exponent. And then the whole thing is called starts with the letter P. Say again?
Pairing something.
No, not a pairing.
No.
Ends with hour. Power! It's a power. The whole thing is called a power, right? So when we talk about a power, we're talking about the whole thing, right? The base, the exponent, the phone not in our hands but put away because it's not out, because we're not listening to music or playing on our phones. We're taking notes. Now, today we are working with some properties of exponents. We're going to start with the first one, the product of powers. All right, so the product of powers says that if you have one power multiplied times another power, and the powers have the same base. So, x to the m times x to the n, then the answer is the same base, and we add the exponents together. So x to the m times x to the n will be equal to x to the m plus n power. Now, I do want to expand this and talk about this, right? So let's do this with some numbers instead of some letters. Let's go with x to the third power, and let's multiply that by x to the fourth power. So, what does x to the third power actually mean? What does it mean if I have x to the third power? Yeah. Nope. Well, that's another way to say it. X cubed is another way to say it, yes. Yep.
Multiplying x 3 times.
Yeah, you're multiplying x 3 times. It literally means that I have 1, 2, 3 x's, right? X times x times x. Is that 3 x's? That's 3, yeah. X times x times x, right? So, x to the third means that. Now we're going to multiply that by x to the fourth, which means 4 x's this time. So now I have 1, 2, 3, 4 x's, right? So I have my 3 x's here. I have my 4 x's here. All together I have 7 x's. And if I just wrote down 7 x's and said, hey, write this as a power, you would write x to the 7th power. And so when we go to do this, we get x to the 3 plus 4 power, which is x to the 7th power. Right? When we multiply with powers, we add the exponents together. Yes?
So when writing down like problems like these, we have to write x 3 plus 4 and then what's that?
Nope. Nope. You can go straight from here to here. That's perfectly fine. Right? I don't expect you to do both. Okay. So, that's the product of powers. Let's try one. Let's play with 6n to the third power times 2n to the 7th power. What do you think is going to happen with this one? How is this going to work? Yep.
Would you multiply the bases and then add the exponents?
I find it vaguely humorous that you say it that way. That is exactly the same way that someone in my third period class said it, right? Exact same phrase. And I'm going to say the exact same thing. I like everything you said except the word base, right? But I'm glad you said it because it gives me an excuse to do the problem after this one, right? So after we finish this problem, we're going to talk about why that's a bad turn of phrase, right? So we are, however, going to multiply the 6 and the 2. But those aren't bases. Those don't have powers with them, right? The 6 is just a 6. It's not 6 to the third power. The only thing being raised to the third power is the n, right? So I will do 6 times... Oh, I should probably grab a pen first. I will do 6 times 2, right? And then we will multiply the n cubed times the n to the 7th. All right, so I'm going to multiply numbers together, and then I multiply things with the same base together. So 6 times 2 is 12, and n to the third times n to the 7th. Very good. N to the 10th power. 12 n to the 10th power. All right, hopefully that's fairly straightforward. All right, so let's talk about this problem. 2 to the third times 2 to the fourth is what? Yes? It will be 2 to the 7th. But I know that there are some of you in the room who are thinking, but Mr. Good, 2 times 2 is 4. This should be 4 to the 7th power. Right? Does that make sense? Some of you are thinking that. I know it. However, for the same reason that we were playing with the x's earlier, this is really 2 times 2 times 2. And then we have 2 times 2 times 2 times 2. And if I asked you to rewrite that, you would write 2 to the 7th, not 4 to the 7th. Right? So even though we can use the shortcut and just add the 3 and the 4, we do not actually multiply these bases together. Right? We just rewrite the base with its new exponent. Does that make sense? 4 to the 7th power is completely different than 2 to the 7th power. So we would have different things. Yes?
So when you don't have a variable, you just keep the number and then...
Well, the key here isn't the variable or the number. The key here is that if you are multiplying with powers, the base stays the same. And what changes is the exponent. Right? Whether the base is a number or the base is a variable. Right? So when we were multiplying the n cubed and n to the 7th, we just wrote n, and then we added 3 and 7 and got 10. If I'm doing 2 to the 3rd and 2 to the 4th, I write the 2, and then I do 3 plus 4 and get 7. Right? All right. So let's talk about a new property. This one is called the power of a power. Power of a power. Now this one occurs when we take a power and raise it to a new power. Alright, so for example, I've got x, and x is being raised to the power of m, x to the m power. And then we're going to take that whole thing and raise it to the power of n. Okay. So if you raise x to the m to the nth power, you get the following answer. You get x to the m times n power. Now again, I want to make sure that you can kind of see what's happening here. So let's play with x to the 4th raised to the 3rd power. When you raise something to the 3rd power, it means that you're multiplying it together how many times? 3 times. So what this really means is that I have x to the 4th times x, x to the 4th times x to the 4th. And according to my last property, when I multiply with powers, what happens with my exponents? They get added, right? So according to my last property, I'm going to take 4 and add it to 4 and then add it to 4, which is going to give me x to the 4 plus 4 plus 4 power. And 4 plus 4 plus 4 is x to the 12th. Well, the shortcut says rather than doing that, you can go straight to here and do 4 times 3. And 4 times 3, of course, is still 12. Right? So the shortcut eliminates the repeated addition. Right? So if you take a power and raise it to a power, then we multiply the exponents together. All right. Let's try another one. Let's do this one. 2 to the 3rd raised to the 2nd, the whole thing raised to the 4th. This one looks complicated, but it's really not all that bad. Work inside out. Start with the 2 to the 3rd power and raise it to the 2nd power, which will give me what? Yep. It will eventually. We'll talk about it again after you get back from lunch. See you in a bit. Here we go. 2 to the 3rd raised to the 2nd power gives me what? Cooper? 2 to the 6th. Right? So now I have 2 to the 6th power, and then that is being raised to the 4th power, which is how we will wind up with, 2 to the 24th. All right, so that's not too bad. All right. Now, from here, we need to talk about the power of a product. So this time we're talking about what happens when I have set of parentheses, and inside the parentheses stuff is being multiplied together, and then we raise that to a power. So all that happens here is each thing gets that power. So this becomes x to the power of m and y to the power of m. So each one gets that power. All right, so if we apply that to, say, negative 2xy cubed raised to the fifth power. I'll leave that up there. What do we think is going to happen here? Wyatt, thank you for volunteering. Not just negative 2x. Like, I think that you're skipping something. Now there's too much. Negative 2 is going to be raised to the fifth power, right? So each individual piece gets raised to each power, right? So this is negative 2 raised to the fifth power. Then we'll raise x to the fifth power. And then we raise y to the third to the fifth power, which gets me what? Yeah. Y to the 15th, right? Y to the 15th. Now, just out of curiosity, what is negative 2 raised to the fifth power? If I evaluate that, what does that get me? Negative 2 to the fifth power. Cooper. Yep. Negative 32. So final answer on this one, negative 32, x to the fifth, y to the 15th. All right. Now, when you simplify a monomial, which is what you'll spend the bulk of today's homework on, is simplifying a monomial. There are three things that have to happen. The first thing that has to happen is that each variable should only be written once, or should only appear once. Each variable should appear one time and one time only. All right? Then there should be no power to a power. So if you have a power that's being raised to a power, you have to simplify that. You have to take care of that part, right? So, so far when we simplify a monomial, each variable should appear one time and no power to a power. The last thing that needs to happen is any fraction should be simplified. Okay, fractions should be in simplest form. Fractions in simplest form. I apologize for my handwriting today. I don't know what my problem is. Let's try the word simplest one more time, shall we? Simplest form, by the way, does not mean mixed number. It just means that it is reduced as far as it will go. Yes?
What do you mean it says power to power?
So, if you have something like this, x to the fourth raised to the third, right? That's a power to a power. So, we need to fix those. All right, let's try this one. We're going to simplify this as far as it goes. Now, the thing about a problem like this is it can appear daunting, but you just tackle it piece by piece. All right, so I'm going to work on the first set of parentheses. And I'm going to start here inside, and I would look to see if there's anything I can do to simplify what's going on in here. There isn't this time, and so now I'm going to go to the outside, and now I need to square everything inside the parentheses, right? And so we wind up with 3, oh, I should grab a pen, 3 squared, and then x squared, and then y to the 4th squared is y to the 8th, right? So we have y to the 8th. Now, I'll put down the parenthesis over here. I'm going to work again inside out. So I'm going to start by dealing with what's in here. There isn't anything to do here, so now we're going to square it, right? So I'm going to have negative 2 squared. And then y squared, and then we raise the whole thing to the 3rd power. All right, so now my next step is to start simplifying some of the numbers. So 3 squared is 9. So now we have 9x squared, y to the 8th. Negative 2 squared is, no. Negative 2 squared is what? Positive 4. Because a negative times a negative is a positive, right? So negative 2 times negative 2 would get me a positive 4. So that's going to wind up being 4 to the 3rd power. And then y squared to the 3rd power is y to the 6th power. Now, 4 cubed is 64. So now I have 9 times 64. And then we have x squared. And then y to the 8th and y to the 6th. So 9 times 64 is?
Actually, question.
Yep.
So, on the step before this, where'd you get the 3 to go with the 4?
Where did I get the what?
The exponent 3, how do you get that to go with the 4?
Oh, because right here we had that negative 2 being raised to the 2nd power, which gave me the 4. And then the whole thing is being raised to the 3rd power.
And then, why'd you put the 64? Why'd you make it the 4?
Oh, so that I can multiply it with the 9. Multiplication is commutative, meaning it can be written in any order that you want. And once I have all multiplication, I suppose theoretically, can I move stuff here? You're going to be weird, aren't you? Oh, my word. Let's undo that. Not do that. Oh, actually, I think I know how that works. Can I just... Maybe. I feel like it's let me move stuff in the past. That's been weird. I'll have to figure that out. Maybe if I start there, can I... Oh no, all it does is copy it. Well, copying's okay. I guess I can just put that there. Alright, so now let's just get rid of all of this. Alright, so I sort of skipped a step. So I could have left that, let's see, 9, nope, I don't want green. 9, come on. 9x squared, y to the 8th, and then 4 cubed is 64, and then y to the 6th, right? So multiplication is commutative, and because it's commutative, I can rearrange. What are you doing? Oh, stop it. I love technology, except when it doesn't like me. Oh, I just want you to move. Nope, I want that to stay right there. How do I make you go up? Seriously. Seriously? I just want the page to go up. I want the whole page. Not part of the page, the whole page. I am so very confused right now, it's unreal. I'm really annoyed right now because there's still more stuff down there that I need you guys to see. Haha, love technology. I love it when it does new things. All right, well, I'll figure that out in a minute. So 9 times 64 is 576. And then the x squared doesn't have anything to multiply with. Y to the 8th and y to the 6th becomes y to the 14th. And that then is my final answer. Yep.
Wait, so how do you know when to add the exponents and to multiply?
Seriously. What the heck?
It's probably because you copied.
I know, but I don't,
You can't delete it.
I don't, It's never happened before. What happens if I do you? No, you insert new things. I don't want to insert new things. What do? You highlight and delete stuff. I don't want to highlight and delete a whole bunch of things. Let's not do that. I just want you to move. Nope. Nope, that didn't work at all.
Delete the copy part.
I'm so confused. Oh, so you're just going to make all that smaller, aren't you? That's dumber than a box of rocks. Okay. Gosh, that's annoying. I'll put it back here in a minute. I'm so annoyed right now. All right. Your homework, page 395, numbers 21 to 56. Did someone have a question while I was playing with that? I apologize. Oh, you memorized the properties that we just talked about. So we went through and we listed a whole bunch of properties, right? If you're multiplying powers together, right, then it's adding the exponents. If you have a power raised to a power, then you multiply the exponents together. So you got to memorize those properties. All right, everybody have that written down? Get it written down. Page 395, numbers 21 to 56. Excuse me, 21 to 56.